People said this building couldn't be built. There were also those who said it shouldn't be built.
There was a lot of skepticism.
That in a destitute city, devastated by the loss of industry, this was a huge gamble its citizens could kind of do without.
This project was going to be a success for everybody or a failure for everybody.
Philip Johnson calls it, quote, the greatest building of our generation.
But in one last throw of the dice, this building defied all the odds and in doing so, changed the world.
It immediately was hailed a masterpiece when it opened in 1997.
Today, we're used to seeing buildings that defy the laws of physics, but back in the early 90s, when work first began on the Guggenheim Bilbao, there was nothing on Earth that looked anything like this.
Considered by many to be a masterpiece.
We got to maybe push things further than have ever been done going forward.
It was built using software developed to design fighter jets. It kick-started the use of 3D tech, leading to a revolution in construction. It made a global superstar its architect and transformed its host city from a downtrodden backwater into a thriving global destination. And if all that weren't enough, it was so successful it went on to become a template for urban regeneration that is still in use today. In fact, you're probably living near somewhere that was inspired by this structure. How it was built is a story that involves Russian submarines, rock climbers, and a giant fish. But most remarkable of all is the fact that despite its outrageous design, it was completed on time and on budget. Our story begins back in 1991 in northern Spain. Forget the sun, sea and sand of the south, this is the Basque Country, Spain's historic industrial heartland. It was an area of mines, factories and more than its fair share of rain. Its largest city, Bilbao, had been a prosperous hub of heavy industry, with steelworks and shipyards lining the Neveron River that ran through it. But as the world changed, its industries couldn't keep up with overseas competitors, and in the 1970s, it fell into long-term decline.
Bilbao was, and the whole region at that time was undergoing a fairly fundamental crisis. The city, which had been a very wealthy area from the end of the 19th century through the end of the 20th century, was undergoing a major challenge.
As industry collapsed, the city was gutted. Between 1979 and 1985, a quarter of all industrial jobs were lost.
And 1991 is a moment where, just to give you an idea, it was just 3 years after a fairly important shipyard, which was located very right in the middle of the city, had closed. The Schengen Treaty was signed. Spain was just 5 years into the European Union. It was just 3 years after the Berlin Wall had fallen. So it was a moment of change.
Bilbao was down but not out. The Basque government seized the moment and decided to fundamentally change the economy of the city, placing at its heart an industry that few people would have associated with this place beforehand. Tourism.
Nobody believes that. Well, we have talked about the social crisis, the industrial crisis, unemployment, both terrible, tragedy. You join that with Bilbao, the ugliest city in the world. Horrible.
The plan was ambitious, blending practical infrastructure with landmark projects, all driven by major international architects. Foster & Partners was commissioned to design the city's first metro, while Santiago Calatrava was brought in to create a new pedestrian bridge and a modern international airport. But the centrepiece would have to be something truly extraordinary. A museum big enough and bold enough to stand alongside the world's greatest cultural institutions. To do this, the Basque government partnered with New York's Guggenheim Foundation. The government agreed to put up $100 million to pay for the building, as well as a one-off payment to the Guggenheim to license its name and allow access to the foundation's collection. But with such a huge amount of taxpayers' money being spent on a speculative project when unemployment was sitting around 20%, the public reaction wasn't great.
The project itself was very controversial from the beginning. There was a lot of resistance to the idea of the public institutions spending money in a cultural institution instead of the more kind of basic needs of the time.
A competition was held to choose a design for the museum, with participants given just 2 months to develop a proposal. To avoid any further controversy, 2 very clear stipulations were made right from the outset. Under absolutely no circumstances could this project be late or go over budget. And with those 2 things in mind, this is the design they chose.
The panel decided on Frank's design, which, although it was probably the one which made everybody more nervous about how can you build that, it was fairly clear that it was the one who had understood and reflected better the different goals for the building.
The panel had reason to be nervous. Frank Gehry had built a reputation for innovative, eye-catching designs, but his latest venture, the Walt Disney Concert Hall, was making headlines for all the wrong reasons. Commissioned in 1987, by 1991 the project was entering a long hiatus as engineers struggled to work out how to build it, and funding and planning issues stopped any significant progress. With an even more audacious design for the Guggenheim Bilbao, serious questions were being asked about whether it was even possible.
There was a lot of skepticism, and there was a lot of criticism also even from the architectural world, saying, well, this building cannot be built, or cannot be built on time, cannot be built on budget.
But this project would be different. To pull off his most daring design yet, Gehry had an ace up his sleeve. But before he could use it, his team first had to transform his early sketches into something more tangible, starting with his trademark process of model building. Now, using those initial sketches as a foundation, Gehry's design team began experimenting with models made from paper and card, developing the building's distinctive form through physical manipulation.
There's initial conceptual sketches, they're descriptive gestures of what the building is trying to capture, to then physical models that are initially just, like small, almost like children's building blocks.
From these, the team would develop hundreds of models, increasing in complexity as they balanced creative flair with the practical requirements of the building.
You were working with the form both from a expressive gesture, but then also dealing with some of the work that was happening with the consultants and what their requirements were, how you were meeting floor area requirements, or did you have enough room for the bathrooms that were needed in that area?
Now, designing something this complicated with pieces of card is one thing, but building it is a heck of a lot more difficult. And to explain why, I'm going to need some crisps. For thousands of years, architecture and engineering has run on a set of rules. Buildings were based around flat shapes or planes like squares, rectangles, and triangles. Within those, certain things will always be true. 2 parallel lines will never meet. A straight line can always be drawn between 2 points, and right angles are always 90 degrees. That's what's known as Euclidean geometry. It's named after a guy called Euclid who first wrote about it. It's a big one. You can see this in everything, from the pyramids to skyscrapers like the Empire State Building. But the Guggenheim Bilbao isn't based on flat surfaces. Just take a look at this wall here. Look how it curves out, then back in on itself, then twists around the higher it goes. If we draw a line from here to here, rather than being straight, it ends up looking like this. And if we drew a triangle on it, the angles wouldn't add up to 180 degrees. Shapes like this fall into a category known as non-Euclidean geometry. So Euclidean, non-Euclidean, why does any of that matter? Well, this right here is a crisp, or to our American viewers, it's a chip. Now, this is actually a really good example of Euclidean geometry because it's round, flat, square, no surprises. Now, if you were an engineer and I asked you to build this for me, it would be pretty straightforward. I could draw it from this angle and from this angle, and you'd have a pretty good idea about what I was after. Now imagine I've asked you to build me a Pringle, which would be a pretty strange request. But basically I could show you it like this, and it would look flat. but turn it this way and you realise it's curved not just in one direction, but in two. I can't accurately draw this in 2 dimensions because it doesn't follow any of the rules that allow me to do that. I could give you the gist of it, but that's not really good enough. Engineers need precise measurements to be able to carry out their work. To really show you how to build this, I would need an advanced piece of software. Enter CATIA. CATIA is a 3D modelling software first developed to help design the French Mirage. But in the early 1990s, it was making a name for itself in the design of the new Boeing 777, touted as the world's first paperless aeroplane. Computer design packages were beginning to make inroads into architects' studios, but what CATIA offered was revolutionary. Because it was based on mathematical equations rather than polygons, it allowed the team to model complex 3D shapes and from that model provide accurate cross-sections and plans to engineers.
So at the time, the prevalent way of working was CAD, AutoCAD, Graphisoft. You could do limited stuff in 3D, but it was predominantly a replacement for 2D pin bar manual drafting, right?
The complex geometries being developed by Gehry's design team were still novel in the world of architecture, but this was all basic stuff for aerospace software which could not only model the complex geometries, but also split them up into components which had precise details about them.
The idea that there was maybe an overall shape to the airplane or car, and then pieces would be fit into that, and then those pieces would be distributed from manufacturing. The whole thing would come together virtually. You would test the plane, and then you'd build it, and it would work, right?
But the first time Gehry used the software, it was to design something more used to swimming than flying.
Well, yes, that was pretty innovative at the time, and we already had some early successes using the CATIA technology through like our Barcelona project, which was built in 1992.
Gehry had been commissioned to design a sculpture for the 1992 Barcelona Olympics. What he designed was this: the pêche, or fish. Now, granted, it doesn't look super complicated, but just like the Pringle, it's based on a series of huge curves that are almost impossible to describe on paper. So for a solution, his team turned to CATIA.
We were doing it through traditional drawings and it just wasn't working out, and we found some support outside the office that had aerospace and aeronautic background.
This strange new software had proved its worth and was seen as the key to unlocking the daring design of the Guggenheim. Now, for any Gen Zs out there thinking, well, so what? It's worth remembering just how basic digital tech was back then. At this point in the early 90s, most people had never used the internet, mini-discs were the latest way to listen to music, and cutting-edge computer game graphics looked like this.
And this sounds crazy, but the ability to do real-time rotation of shaded models, you really didn't see it anywhere before. I mean, you would work in wireframe, and then there would be this process where you'd render and you'd see over the course of a half hour that image taking place, you know. And just to see somebody being able to like look at a complex shape from all its sides and understand it was, you know, it's not just about the real time, it's interactive, right? So the interaction with real-time geometry for me was revolutionary.
Now, as groundbreaking as this technology was in the 90s, don't think the innovation stopped there, because CATIA has come a very long way since the days of Guggenheim. Take a look at this, for example. It's called the Henderson in Hong Kong, and as you can see, it's absolutely epic. It was also built using CATIA on the 3D Experience platform and really pushed the limits of design and fabrication. The entire skyscraper is covered in more than 4,000 individually shaped panels. 3D Experience models each one and even simulates how they'll be manufactured. Now, when I was first starting out in the industry, I honestly would have thought that something like this would have been impossible because everything is so complex and interconnected. You change one thing and everything else gets affected and has to change with it. But 3D Experience is a real game changer because it updates everything. You make a change to the facade and it updates not just that, but also the structural layout, the internal floor plates, all of it in real time. And perhaps most importantly, every piece of information is managed on the same platform. Trust me, on a project this big and this complicated, with so many people involved, miscommunication happens a lot. So having one model, one kind of like common source of truth that architects, engineers, manufacturers can all refer to is a real lifesaver. You can find out more about how CATIA can help take your project to the next level at the link down there in the video description. It massively helps us out when you guys go and check out our video sponsors and enables us to keep making great content for you. So if it's relevant, please do go and check out CATIA at the link below. With that, it's time to head back to the 1990s. In 1993, just 2 years after winning the competition, construction began. And this is where things got really tricky. CATIA played a critical role, but it didn't have all the answers. It was able to accurately describe what had to be built, but then it was over to the engineers to work out how to actually construct it.
What is CATIA for us? A group of surfaces and volumes. And this is perfectly designed, but nothing at all defined in one sentence. Not ready to build.
While CATIA was great at defining the overall shape of the museum, a lot of work still had to go into how it would be manufactured.
You have a cut, you have a line of perfectly designed the shape of different areas. That shape is titanium, is stone, gypsum board, is glass. But in order to place these materials on the structure, you have to develop the engineering and you have to manufacture this structure, these tubes or steel profiles in arcs of circumferences in order to construct this and then to put the surface, to put the cladding on the titanium and gypsum or stone or whatever.
The job of developing the structural design went to SOM in Chicago, who took Gehry's plans and developed an intricate steel mesh. That would provide a strong frame that could accommodate the building's expressive curves, but crucially also create a large, open interior free of columns. The primary structure was so complex and interlinked that large parts were unable to freestand and were held in place by cranes until it was complete. The design was so intricate that no two steel beams in the entire 3,000-ton structure were the same. But also, none of them were curved. To achieve the facade effect of a single or sometimes double curve, more steel structures were built on top. A secondary frame of curved horizontal beams provided shape along one axis, and a third tertiary structure composed of curved vertical beams provided the definition for the other. Here is the wall we looked at earlier. Look at how the different structures create arcs and curves that a curved surface can be placed on.
They are curves. They are arcs of circumferences in general, depending on the area or depending on the zone. Okay, they could be straight as well, but in general, because of the shape, the museum, they don't have almost no straight lines. They are all curves in one length or in two lengths, depending on the area. But all the profiles, the beams, they are all the primary structure, they were straight. The massive structure was straight, but the secondary and tertiary, they were curves, arcs of circumferences.
Once the structure was complete, work moved on to enclose it. Stainless steel panels were installed to enclose the structure, followed by a waterproof membrane. The Guggenheim Bilbao isn't just about wavy curves. What really strikes you is the warmth with which it reflects the light in a soft, pillowy texture. Bilbao is a city that's often cloudy, and yet the museum still reflects this with its unique sense of warmth and sympathy. But the story of how it took on that character is a series of chance events, beginning 3,500 kilometers away.
I must break you.
This is a Soviet Alpha-class submarine. Developed in the 1960s, it was one of the fastest military submarines ever built, thanks to its innovative engine and the revolutionary use of titanium for its hull. But there was a problem. They were also incredibly expensive to operate.
I must break you.
In 1990, as the USSR began to disintegrate, and in an effort to save money, the Soviet Navy began decommissioning the Alphas. This was actually the first of two chance events that decided the outcome of the Guggenheim. The other came sometime later, on an uncharacteristically overcast day in Los Angeles. Gehry's team had been struggling to choose a material to clad the building in. He'd previously used a lead-copper alloy, but this had fallen out of favour because of its environmental impact. Gehry was unhappy with early tests using stainless steel, which didn't capture the city's distinctive light in an attractive way. On that fateful, cloudy day in LA, Gehry's eye was caught by a piece of titanium cladding on the exterior of his studio. He was impressed with how it reflected the grey sky, which perfectly matched the typical weather in Bilbao. But there was a hitch. Titanium is expensive. It was more commonly used for making components for aeroplanes than for cladding buildings.
I must break you.
But as the Alpha-class submarines were broken down, the titanium from their hulls entered the global market, driving the price down and giving Gehry an opportunity to give the museum its distinctive finish.
You know, it's a very thin 24-gauge metal. Thinness of the panel gives it a little bit of, we call it oil canning, where it kind of puffs a little bit, which gives it its unique kind of textural quality when you look at the pictures and how it captures the light. There's a goldenness to it that's different from stainless steel. There's like a yellow glow to the metal.
33,000 panels were rolled to a thickness of just 0.38 millimeters. With each one measuring just 80 by 115 centimeters, they were perfectly suited to define the final shape of the building.
It was a happy accident that we chose to have a very small panel. It naturally could bend easily over the shapes that we had, which were very gentle curves. When you take the largeness of the building, it looks like a lot of curves, but when you get down to it, you know, you can take a postage stamp, lay it over a basketball, for instance. If you get a small enough stamp, you know, you can cover the whole basketball with stamps.
While the panels may have been small enough to cover the bold, swooping curves of the facade, physically getting them into place was a whole other challenge. The solution came not from the pages of a construction handbook, but from the mountains that surrounded the city. Rock climbers.
Not only the height, there are areas that with cranes, platform, scissors, you don't reach. The people must climb and then to go down the surface. Now, when they have to clean the facade, they have to use escalators. They have to the climbers. You have to use climbers.
As this extraordinary building rose along the banks of the Neveron, so too did the city's admiration, transforming skepticism into awe in the heart of this old steel town.
I will say the first year, everybody was shocked. This is a stupid thing, this is absurd. But the point is that little by little, the building, the construction, the structure was connecting with people. Little by little, people were falling in love with the project and began to believe.
On the 18th of October 1997, 4 years after construction began, the Guggenheim Museum Bilbao opened. And as the eyes of the world fixed their gaze on this extraordinary structure, signs began to emerge that the gamble had paid off.
I remember when the museum opened that it was headline news at the CNN news program, which at that time was the only global news source. And that was a bit of a surprise for us because we thought, how is this happening? That an opening of a museum in a small city in north of Spain is becoming headline news at CNN.
The building instantly captured the imagination of everyone, from locals to international spies. The museum had planned for around 400,000 visitors, but in its first full year of operation, it welcomed over 1.3 million.
In our initial plans, we thought we would need 8-10 years of good operation to really capture the interest and imagination of the world. But the fact that it was new since the very beginning, it meant that the museum was already in the imagination, not just of people living close to us, but far away.
Innovative, transgressive, and creative.
We came all the way over here from Vancouver, Canada, just to see the museum.
For me, the museum is beautiful, aspirational, and inspiring.
As the museum thrived, so too did Bilbao. The plan to reinvent the city was bearing fruit. The metro had opened 2 years before, and the Campo Volantino footbridge followed suit shortly after, improving pedestrian access along the river on which the museum sits. In 2000, the new airport terminal opened, giving a further boost to visitors from around the world, and transforming Bilbao from a downcast regional city to a thriving global destination. Bilbao is once again a major, prosperous city. Its streets are teeming with locals and visitors enjoying everything this place has to offer.
Last year, for example, it's estimated that it was over 800 million euros of additional economic activity because of the operation of the museum.
What I feel when I go back to Bilbao and I see a great success, when I see the change of the city, when I see the 1 million people going to visit Guggenheim, the vitality, the lively restaurants, people, tourists, the change has been huge.
The Guggenheim was such a wild success that it kick-started a wave of museum construction around the world. In 2000, the Tate Modern opened, revitalising London's decrepit South Bank. And in 2010, a new Pompidou Centre transformed the French city of Metz. But the list really is endless. In fact, the chances are there's probably somewhere near you which has tried to follow the template of using a major art or cultural centre to transform the fortunes of a town or city. Its impacts even shaped the construction industry, kicking off a revolution in design and technology that still defines it today.
The role of technology and information was the kind of the silver bullet that allowed these very ambitious designers to do unprecedented, buildings and to have the confidence that they could take that authority and that risk.
Gehry's outlandish design didn't just pioneer the use of digital software in architecture, it fundamentally changed the relationship between the architect and the engineer.
Architects are supposed to not get involved in affecting how things are built. They're just supposed to say, when they're built, this is what they look like. But these new geometries, these new methodologies, that line between what is intent and what is the means of delivering it starts eroding.
The complexity of the design puts a much heavier emphasis on the role of the architect's model. In a more traditional workflow, an architect develops a series of plans, an engineer then takes those and creates their own set of drawings, and then finally it all gets passed on down to the contractors and so on. But the complexity of these non-Euclidean designs places more emphasis on the importance of the architect's model, which in turn adds more responsibility to the architect to make sure that coordination between all the different disciplines happens as effectively and clearly as possible.
So the idea that the architect's model would become the basis that everybody does their work off of was revolutionary and also, frankly, risky. Because you can imagine a curved shape like Bilbao. If I say, well, the surface is here and your structure is going to be here, you're setting off a chain of decisions that if there's an issue, everybody can just point back to that original shape and say, well, that must have been the source of the problem.
It may have been risky, but for Gehry, it worked. Along with his highly collaborative approach, this greater level of involvement is what helped this extraordinary building complete on time and on budget. In 2002, Gehry Technologies was established, a service firm which was hugely influential in the widespread adoption of 3D modelling and BIM software throughout the architectural profession. It would go on to enable countless iconic buildings like the Bird's Nest Stadium in Beijing and the Louvre Abu Dhabi. For Gehry's practice, meanwhile, his reputation as an architectural heavyweight was confirmed, and it provided an opportunity to correct the record of a building that had once threatened to tarnish his legacy.
the Walt Disney Concert Hall in Los Angeles was in that moment had been delayed or stopped for 10 years, I don't know, and they were unable to push the project. No? And I remember that Gehry sent to Bilbao one of the contractor, or the main contractor of the Walt Disney Concert Hall, to talk with us to see what we had, what we were doing in order to be able to construct, in order to be able to keep to the budget.
After Bilbao, when Disney got resurrected, Frank said, we will only do this if we are the architect of record, and we will only do this if this process is adopted.
The Walt Disney Concert Hall opened in 2003, 16 years after it was commissioned. It was widely hailed as a masterpiece and remains an iconic landmark in Los Angeles. Meanwhile, back in Bilbao, the Guggenheim still stands as an iconic destination in the city. It's a timeless structure that still amazes visitors to this day.
Bilbao. Frank Gehry, you're a genius! Behold, the new Springfield Concert Hall!
Telling a story like this really is like reading out a list of things that we today take for granted. The idea that a museum could be an international tourist attraction, the technology, the 3D design. All those innovations, like ripples in a pond, have to start somewhere. And in this case, that single point is the Guggenheim Bilbao. This video was sponsored by CATIA. You can learn more about them at the link below. It massively helps us out when you guys go and check out our video sponsors and enables us to keep making great content. So if it's relevant, please do go and check out CATIA. We would really, really appreciate it. And as always guys, if you enjoyed this video and you want to enable me to eat more crisps on camera, make sure you're subscribed to the B1M.